Let us see this problem. This is an integer based problem. Right? So what the question says, an infinitely long solid cylinder of radius r has a uniform volume charge density rho, right? It has a spherical cavity of radius r by 2 with its center on the axis of the cylinder as shown in the figure. The magnitude of the electric field at point P, which is at a distance 2r from the axis of the cylinder, is given by the expression this much. What is the value of K? So in cases of cavities, what we do is we fill the cavity by charge density plus rho and minus rho respectively, right? So when we fill it by plus rho, it forms a complete solid cylinder, right? It forms a complete solid cylinder without any cavity. So we will see the effect due to it at a point P, which is at a distance of 2r from the axis, and the radius is r, right? So what we do is, if we have to calculate electric field at a point P, we draw a Gaussian surface, a cylindrical Gaussian surface, right? Let us assume the length is L. So what will happen? E dot ds will be equals to q enclosed upon epsilon naught. So ds will be equals to what? 2 pi into 2r into length L, right? This is the ds. What will be q enclosed? Q enclosed will be the total charge in the cylinder. So rho into pi r square into L, right, divided by epsilon naught. So we can very well simplify this, and we will get, it implies E1, let us call this E1. E1 will be equals to rho r divided by 4 epsilon naught, right? This is our first equation. Now let us see the electric field due to this cavity, which is filled by minus rho charge. This is the cavity, or let us draw it over here. This is the cavity, and we have to calculate the electric field due to it. This is having a charge density minus rho, right? And its radius is r by 2, and we have to calculate the electric field at a distance 2r from it, right? So again we can use the Gauss's law. So again we draw a Gaussian surface. That means E dot ds. What is the surface area of this Gaussian surface? That will be equals to 4 pi into 2r, that is the radius of the Gaussian surface, whole square. This will be equal to q enclosed. Q enclosed will be equals to minus into rho into 4 upon 3 pi of r by 2 whole cube divided by epsilon naught, right? This will be the electric field. This will be the Gaussian law basically. So we can simplify this, r square, and this implies that E2, let us call this E2. E2 will be equals to minus of rho into r divided by 8, and 4 will be coming over here, 4 into 3 epsilon naught, right? This will be equals to minus of rho r upon, this is 96 epsilon naught. So net electric field will be given by what? E1 minus E2. So this will be equals to, what we can do is we can take rho r upon epsilon naught, rho r upon 4 epsilon naught as common. We will be getting 1 minus of 1 divided by of, what will be this? This will be 24, right? 24. So this will be equals to rho r into 23 divided by of 24 into 4 epsilon naught, right? Now if we see the question, we have to calculate the value of K. So we need 16. 24 can be simplified as 8 into 3, or I can simplify this as 6 into 4. 4 into 4 will be 16. So that means K will be equals to what? 6. This is my answer. That means the integer based answer is 6.